talk about JavaScript. This morning, Richard explained about the differences between parallel coding, sequential coding. I like to call it synchronous versus asynchronous. Yeah. So, in that respect, we've got two things, more than two actually. So, I think last week Ray talked about callbacks, right? Callbacks. Have you done the higher order function training? Yeah, callbacks, all these things, right? Callbacks is the primitive mechanism to deal with asynchronous JavaScript code. However, that was very painful, right? Probably you've seen, if not, I'll show you now, something called callback hell. Look, callback hell, Google, images. It's callback hell, right? Sorry, you cannot see anything. Right, here you go. Callback hell, right? This is tough. It's hard to read. That doesn't scale at some point. Because of that, one guy, long time ago, he created a library called Q. The Q library was something that someone created, open source project, like something we can do, and that was a proposal to improve that picture, yeah, to be able to create maintainable code. That library became quickly very popular, to the point that in 2011, Angular, have you heard about Angular before? Yeah, Angular adopted it. They introduced something called $Q, which was a simplified version of Q. So the guy started becoming popular. His idea was really good. And the popularity just kept increasing and increasing, to the point that recently the JavaScript standard decided to accept it. So now that idea that guy had on his mind is part now of the standard of JavaScript, which is amazing, right? That means that his tool is not necessary anymore, but hey, he has contributed to the standard. That's literally amazing. So, thanks to promises, now it's much easier to deal with asynchronous coding. However, because that's still a bit painful in some cases, that has evolved even more with something called async await. I have to admit that that's by distance my favorite feature of modern JavaScript, async await. So let's first of all talk about promises. I'd like to do some examples. So let me create a function, do stuff 1. And as part of my do stuff function, I want to return a promise. You learned promises last week with Grace, so can you please tell me the syntax? How do I return something as part of a promise? Return new promise, I love it. I mean, what? Resolve, fantastic. And then here we do our magic, right? So for instance, look, can anyone tell me what I'm typing now? So can anyone describe what is this function doing? Correct. After 1 second, it will return hello, right? Let me copy and paste it, because I want to create a very similar function called doStuff2 that essentially, after you'll tell me, it will return world. What time is that? Half a second, 500 milliseconds, right? Okay, so we got two functions. And now the question is, I want to invoke both, but in reality, I want to call doStuff2 only after doStuff1 is over. I want to create a sequence. Is this parallel coding or not? You know the answer, Richard. Explain that this morning. It's one after the other, correct. So I don't want to do parallel coding. Why not? Because look, I'll make it even more complicated. As part of do stuff one, I get a variable. I pass a variable. And then here, I will return, can do it, something like that. And to make it even more complicated, the output of the first function will be the input of the next one. The example is a bit stupid, but I hope you get the point, right? All right. Can you see the screen, guys? Yeah? All right, cool. So I got two functions. So let's see how can we establish an order. So do stuff one takes 1 second, do stuff two takes half a second. So I'm going to call do stuff one at the bottom, and I'll pass Jack. And now, the way I said, okay, and only once do stuff one is over, then execute stuff two, do stuff two is typing .then. Yeah? It's quite breathable. Do that, do stuff one, then it could take 1 second, 2 seconds, 3 hours, right? We don't know. Then, look, let's put here response. So this is a callback function. This is what do stuff one is returning. So then, do stuff two. And I can pass the response. You see, the output of the first function will be the input of the next one. You know how a car is built, right? They have like a big chain, and there is one step, they put the wheels, and then the car moves to the next step, and they put the windows, whatever. Yeah, I have no idea how the car is built, but that's the main principle. And look, then, again, you see, then, so let me call it response one. I got response two, and then what? Then, I don't know, let's do a console.log. So the message is response 2. Can anyone tell me what response 2 will be? What will this code output? Undefined. Why undefined? Let me show you again the code. Do stuff 1 receives X, and it returns hello X. Do stuff 2 receives Y, and it returns world Y.
I think it will get the message is a result of X, but not Y.
So, Patrick, to simplify things, yes, response 2. Can you tell me what's the value of response 2? Yeah? Hello X, which is in the first row. Hello X, and then what?
And then undefined the second response.
Hello X undefined. All right? Iwan, you wanted to say something?
Yeah, I was going to say it's going to return world.
Only world. All right, Nilofer. Undefined. Anais. So Nilofer and Anais. All right. Vincent. Undefined. And And then we got Abdul. Yep. Walled undefined. All right. And is Richard the last one? Yes, Richard. Walled. Hello, Jack. Only one person got the job. Who is that? I put my name. Sorry. That wasn't opinionated at all. I never wanted to say he was right. Anyway, because I can see that this is not obvious, let's add some breakpoints to make everything even more complicated. No, sorry, let's first of all, let's run it. It's going to be too complicated if now we add breakpoints. So, let's see the answer and then let's evaluate it. We run it and we wait. Well, hello, Jack, which is literally what Richard suggested. Why is that? Look. Say again? Yeah, you could, halfway through, correct. So we could do stuff 1, passing Jack. That's our input, right? So then we go here. What's the value of x? Jack, correct. So what, on line number 5, what our do stuff 1 function returns after one very long second? Hello? Hello, Jack, correct. That's the output of do stuff 1, right? All right. Is this a pure or an impure function, based on what Richard explained this morning? It is a pure function, right? It's deterministic. If we pass Jack, it always returns Jack. If we pass Abdul, it always returns Abdul. There are no side effects. Yeah? All right, so do stuff 1 returns hello, Jack. And now, look at what we do. Response 1, that is hello, Jack, is now the input of do stuff 2. So we come here and the value of y is hello, Jack. Correct. It's still hello, Jack. So finally, do stuff 2 returns world hello, Jack. It's a bit stupid, right? So it's a weird message, but hey, it's the way it works. And that's what we eventually print at the bottom. Yeah? So that's the way promises work. Let me ask you a question. There are 2 points on the board challenge for the right answer. Many breakpoints, guys. So, E1, can you tell me the execution order? It's going to be a bit complicated, to be honest, to see, going up and down. But let me know if you want to scroll one direction or the other. Yep. Right, timeout. Nilofer. 3. I'm going to do, you know what fail fast strategy is? Do you remember, I think it was last week, or was it yesterday? I don't remember. When we talk about unit test, linting, last Friday, correct. So we say that the quickest tasks should run first, because if they fail, we don't waste 30 minutes of our life waiting, yeah? So this is what we call fail fast. So I'm going to do fail fast. Fail fast means, as soon as one of the numbers is wrong, you're out. I'm not giving you the chance to keep talking about invalid things, right? So Nilofer is out. Anais, Yep. Timeout. Vincent? All right. Abdul? Yeah, I'm at the bottom. I can scroll down like that, but it's not going to help you. Yeah.
18.
Yeah.
Scroll up again.
Yep.
3.
Yep.
Scroll down.
Four. Yeah.
5.
Yeah.
Scroll down. Oh, 11.
Wrong. But hey, he managed to. Yeah. At least the feeling Abdul gave me is, even though he didn't manage to find the answer, he understands the flow. So it's good, Abdul. Patrick.
18.
Yeah.
4, 5.
Cool. That was easy, right? 11. No, maybe not. Maybe not 11. Probably not 11. What's next?
3, 4, 5.
Yeah.
19, 11, 12, 13, 20.
I think that's correct. I think that's correct. Let's run it. 18. Yeah. The thing is, Nilofer, it doesn't make sense to start on line number 3.
Actually, I thought that was not the.
All right. So first of all, we stop here. And now say, what do we do here? Please call do stuff 1. No problem at all. We go to line number 3. And then we go to line number 4. And now you'll see some time gap between line number 4 and line number 5. How long will it take to stop on line number 5? 1 second, correct. That's it, you see? And after 1 very long second, do stuff 1 is over. That means, and this is where Abdul failed, we stop here. Yeah, look, boom, 19. We don't go to 11 yet, because to go to line number 11, first we have to invoke do stuff 2. Does it make sense, Abdul? All right, and then it's literally the same thing, right? Do stuff 2. So we'll go to 11, then to 12, after half a second. That's the longest half a second ever, right? It should clearly stop on line number 13, but that's a classic problem with DevTools. Remember that DevTools is sometimes not really reliable. It's not stopping anymore, right? This thing happens. And whenever that happens, I mean, now it's okay, but that may happen in a job interview. I'm 100% sure the algorithm is correct, right? Because we proved the output. And also, because we've run it before and we saw it to stop on line number 5. If that happens on a job interview, let the employer know that's a problem with, I think, don't be very bold because you may be wrong, right? It looks like there's a problem with their tools. So what do you do in that case? Type debugger, yeah, you can type debugger. You can, first of all, copy whatever you've written, close the tab, kill the browser, open it again. And in worst case, don't panic. Just be honest, like, I think there is a problem with DevTools. I'll try to explain what, in my opinion, the flow is, right? So, yeah, this thing happen. All right, so, yeah, that's the flow. And, I mean, it works. It works. How long this snippet takes to complete?
1.5.
Correct, 1.5 seconds. Because they depend on each other. Well, not, they don't depend on each other. Do stuff 2 depends on do stuff 1. But now, what if they don't depend on each other? Imagine that their do stuff 1 x returns hello x, do stuff 2 y returns wall y, but in reality, the output of do stuff 1 has nothing to do with the input of do stuff 2. In other words, we can trigger both functions in parallel. How do we do that? I don't think you did that last week with Gray. Have you ever heard of promise.all? All right, let's do something. Let's create a function called do stuff. And do stuff will call do stuff 1, blah, 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 do stuff 2, blah, blah, blah. The thing is, if we do that, it could be complicated to capture the value because these two functions are asynchronous. They return a promise. So the way we control their execution is by doing this. Look, return promise.all. Be careful with the syntax. When you return a promise, you do return new promise. You see? When you use promise.all, you don't use new here. That's a bit controversial, right? But this is what it is. And look at the syntax. Promise.all receives an array. Here you pass an array of promises. So you can do that. Do stuff 1, hello, comma, do stuff 2, not hello. So that was Jack and that was Wednesday, right? It's a completely stupid example. All right. And once we do that, we got then. So then that callback will run only after every single method here is over. So, first of all, can anyone tell me how long that console log will take to execute? I give you 3 options. Option A, 4 options. 5 options. Option 1, half a second. Option 2, 1 second. Option 3, 1.5 seconds. Option D, 24.5 seconds. Option E will never run.
1 second.
Why 1 second, Nilofer?
Because both are running parallel. Stop 2 will run in half a second and stop 1 will run.
Correct, correct. Nilofer is right. Because we're using promise.all, we say, hey, let's go. 1, 2, 3, go. It triggers all the functions in parallel. And then it will capture the response as soon as every single function is over. That means that the performance of the function depends on the slowest one. Yeah? Which one is the slowest one? Do stuff 1, because it takes 1 second, right? And can anyone figure out what type of data response is? Richard said an array of results. That's correct. That's correct. Because we have 2 functions, we have 2 responses. That's why I find response in singular a bit misleading. I like to call it responses. Because I will be an array. Let's see if it works, first of all. Right, it's not returning anything, but let's figure out why. Let's add some breakpoints. Look, breakpoints are not even working. I cannot add a breakpoint on number 23. That's smelly, right? Ah, look, now it's back. And then what? Yeah, let me add debugger and see if it helps. Oh, it's out of control now. I got the what? No, that should be fine. Look, you see? I cannot add a breakpoint. Whenever that happens, that's smelly. So, following my former guidelines, I'm going to completely switch down. I'm going to open an incognito. Sometimes that tool struggles to deal with extensions, you know, all these things. So I'll go to incognito and I'll create a new snippet, and I'll paste it again. Look, now at least I can add a breakpoint. Now to stop on the breakpoint. So my theory was correct. It wasn't our fault. It was Google Chrome's fault. And actually that's really good, because if you do that, you prove problem-solving abilities. That person had an issue, he or she figured out how to deal with that. And actually, look at the array. Responses, you see? That's correct. Hello Jack, Wall Wednesday. So Richard was essentially right. Look, that's it. Hello Jack, Wall Wednesday. So that works. Richard also explained this morning, talked a bit about object destructuring. If you remember, when dealing with functions and stuff like that. So we can destructure that. Or let me rephrase that. How do we display the first response? So first response is, how do we access the first element of an array? Square bracket 0. That's correct. Another question is, you see, now it's not working anymore. So that's a bit unfortunate with Google Chrome. Are we going to do that every single time we run this? I don't know if that's a good idea, but yeah, it's completely, it's unresponsive at the moment. Anyway, that's correct. That's the way we access the first result. But the question is, what's the first result? Is it the output of the first question, of the first function, or is it the output of the first function that finished regardless of the order? Because do stuff 1, it took 1 second. So, however, do stuff 2, it took half a second. So in reality, do stuff 2 finished earlier. So then, what that represents? Does it represent the order of triggering or the order of finishing? Finishing? I'll show you an example. In this particular case, we have full control on the duration of every function because we hard-coded it. Yeah? But imagine that we're calling the backend, like everyone has been doing recently, right? To get the list of TV shows. How long it takes a request to the backend? But yeah, milliseconds. But we don't know. Is it 10 milliseconds, 20? It depends, right? Depends on the network. It won't take the same time with using here our Wi-Fi than with my smartphone on the Jubilee line, right? We don't know. Because we don't know, the thing is we cannot guarantee it, generally speaking in real life, if do stuff 1 will finish before or after do stuff 2. We don't know. We don't know. Because of that, that array represents the order the functions were declared, not the order the functions were resolved. Because we know that do stuff 1 was declared before do stuff 2. It's an array, right? So response 0 represents the output of do stuff 1. Yeah? So if we run it, it won't work, but it will display hello Jack. Right? And that's correct. However, let me show you how to destructure responses. Probably you've seen that already. Look at how sexy this is. You see? I got an array, and now I can destructure it. In other words, whatever the first response is, please assign it to this variable. Whatever the second element of the array is, please assign it to that variable. Object destructuring. That helps on readability. I think that's better than doing square bracket 0, square bracket 1. Yeah? All right. Any questions? No? I know it's a bit out of time. It's up to you guys. Do you want to do async await? Yes? All right. So async await, I'm necessarily going to repeat the same workshop, but using async await instead of promises. At the end, I would like to show you how I managed to solve the new Google sign-in button. Do you remember in the code? Because I've used it and it has simplified the code a lot. I needed like 65 lines of code to do that with async await, with promises. It's not because of the lines of code, it's the complexity to understand with so many callbacks around. So, again, I will leave promises on do stuff 1 and do stuff 2. So these two functions are going to remain untouched. We've got two functions that return two promises. However, as part of my new do stuff function, I would like to use async await. In other words, I'm not going to type .then. How can we do that? Let's prove both scenarios. First of all, sequential order. The output of do stuff 1 is the input of do stuff 2. Do you remember that example? Yeah, fantastic. All right. So whenever we deal with async await, the very first thing we need to do is to declare, to tell JavaScript, hey, be careful, because in this function, I'm going to deal with await. And to do that, we need to add a sync prefix. So if we do that, JavaScript will understand, oh, this is a good developer, so I need to be careful with him or with her, right? So that's the very first thing. We've done nothing, we just alert JavaScript, be careful. And now, let's recap. Before we did that, let me summarize that. We did do stuff 1, .then, response, do stuff 2. Remember that, right? I don't want to do that because that sort of hierarchy goes against readability. Not in that particular case, that's pretty readable. But as soon as the complexity of the exercise grows, it could be complicated to understand it. So instead of doing that, look how sexy this is. Await. That's it. So you said, okay, please, I want to create a variable, and the variable will be assigned to whatever do stuff 1 returns. That's pretty sexy, because we are transforming an asynchronous function, a function that takes 1 second to execute, into a synchronous one. So now we can do that. So that could be response 1, and then let response 2 equals what? You tell me. Await. What else you want? Do stuff 1 again? 1, 2, or 3? 2. And what do we pass as the argument here? Y. What do you think? What's Y? What's X? Are these arguments correct? No, that was Jack. And that was what? What do we put here? Response 1. You see? Whatever the first function returns, response 1, we pass it to the second one. Yep. And finally, look, we can return response 2. It's much easier, right? That finally, after 13 years of, no, 23 years of JavaScript, finally we have a way to transform, at least from a visual perspective, asynchronous code into synchronous. So now, what do we do here? Every time we type async, and that's important, that means our do stuff function will return a promise. In other words, here I can do .then, that. So let's do something. Let me again copy the snippet, close the tab, open a new incognito, because I really want to see what that snippet actually returns. Can anyone tell me the answer? Probably we need to move up and down. Well, X is Jack, right? That should be enough to calculate the eventual output. So Nilofer proposed hello, no, Walt, hello, Jack. What do you think, guys? Do you agree? Do you disagree? Does anyone disagree on that? That's the same example we ran before. In other words, if Nilofer is right, it proves that the theory is correct, because we just refactor the code to return the same result. Let's see if it works or not. Look, it does work. Well, hello, Jack. How long it takes to complete this snippet? You don't know, but Nilofer knows. So Nilofer, can you express your thoughts? You think 1.5. Why?
Because this is in series and synchronous.
Yep.
So first, it is like, first it will go,
Yep.
the let function, the first function will be, stuff 1 will be executed.
Yep.
Then the result that will take 1 second.
Yep.
Result, stuff 2 that will
That's correct. That's correct. So there are no advantages, technically speaking, right? It's not any faster or anything like that. It's the same thing, but from a human point of view, it's much easier to code and to understand and to maintain. So I strongly recommend you to start dealing with async await. So that's in case both requests depend on each other. Well, one request depends on the other, but we also learn promise not all. So can we do that? Look. You get the idea? It's the same thing, right? Promise not all, that means I want to do parallel coding. So call that function both in parallel, and only once both functions have been successfully executed, capture the result. So what type of data responses is? It's an array, correct, the same thing, right? Let's run it again and see if it works. That's correct. Hello, hello, wall, wall. It's a bit stupid, right? Because we pass hello, and then we do hello, hello, then we pass wall, and then we do wall, wall. But this is what it is. So how long now this algorithm takes to run? 1 second. That's correct. 1 second. Yeah? And that's the same thing. Can we actually make it even sexier? Look, we create a variable, and then we return it, which is okay, but can we do that? Why 1 second? Can anyone tell Iwan why 1 second? Correct, because both run in parallel. How long do stuff 1 takes to run? 1 second. How long do stuff 2 takes to run? Half a second. Because it's the slowest one. Yeah. So JavaScript will wait on line 22. Well, not on, yeah, more or less. It will wait on line 22 until these two guys finish the race. So I was asking if we can simplify things a bit by just doing that. You see? Return, await, blah, blah, blah. And nothing should change. Here you go. Still works. Hmm? So that's the way async await works. Remember, you need to add the async prefix on the function, and then you can use await. If you are using promises on the backend node, please make sure you have a recent version of Node, because promises were recently supported by Node. I think version 9 something. I think everyone should have version 9, but just in case. Yeah? Any questions?
Yeah. Yesterday Gray used resolve, reject.
That's the unhappy path. That's the unhappy path. We got the happy path and the unhappy path. So what's the happy path? The happy path means you press a button, you press like on Facebook, and you assume it will work, right? The unhappy path means you press like on a picture of someone naked on Facebook, and it doesn't work. Then you get an error. Yeah?
Okay, so you will only use reject if you don't want the user to.
Correct. To be honest, I didn't want to talk about the unhappy path because otherwise it could be a bit overwhelming. But I strongly recommend you, and if you consider this is vital, we can do a separate session, no problem at all, to check how reject works. So as part of our promises, we are always resolving them. But in some cases, look, we can do that. We can pass a second argument, reject, and that means that we could ruin the entire execution. Yeah? Again, I don't want to do that now because otherwise it's going to be very long. But yeah, I strongly recommend you to have a look to reject. It's the same thing essentially. Yeah?
So usually you would only use that if you have a sort of condition, like say
Yes.
you need to be over 18 to access that content.
That's correct. You reject the promise when something is not as you expect. Yeah? Right. So let me show you a piece of actual code. So that's real code on the Codere platform. And this is the new signing functionality for reference purposes. What that means? That means, if anyone is not aware of that if it's your first time at Codere, you have a big sign in with Google. When you click on it, then you can sign in using Google, right? And at the end of the day, we essentially check if the credentials are right or not in the backend. And to do that, again, I'm not going to ask every single line, but just to give you the feeling about how does it look like using async await in the backend. We get a function, and essentially, look at how many times I'm using await. That will be a nightmare using then. I particularly like that bit. I love it. Why? Let's try to understand these 3 lines. So with Google, you can sign in or you can sign up. If it's your first time, we'll create a new user in the database. If you're a returning user, you are signing in effectively. So look at what we do here. Look at that line. We ask the database, please, is there any user with email sexyboy19@gmail.com? And that players is an array, right? So here, what do we do? If there is at least one element on the array, I mean, to be honest with the email, there could be only one. But still, technically speaking, if players.length is 1, what that means? Correct, that user already exists. So if the user already exists, then we want to sign in. And that means we maybe need to update something in the database like last signing time or something like that, right? But this step, actually, that step is asynchronous because we go to the database, it may take half a second. It returns a promise. But I'm not doing .then. I'm just using await to wait until the request to the database is sorted. And likewise here, right? Give me the player. If the player already exists, then I just need to get it from the database. If it doesn't exist yet, I need to create a new element, a new document in my collection in the MongoDB database, right? So that's pretty much the way it works. There is a lot of asynchronicity, a lot of complexity. Let me, I'm not sure if that's a good idea. No, I'm not going to do that. I wanted to rebuild that quickly using promises, but that will be mind-blowing, right? So yes, bear in mind that async await, very important, simplifies the code. Also, this is very sexy from a market point of view because many companies are migrating to async await. So if you know that, they will be highly appreciated by the employers. And I think that's pretty much it, guys. Is there anything else you want to talk about? No? Cool. So that was it. Thank you.